presentation is on my scratch build of the single-holed Aleutian or Aleut hunting Bidarcus, also known as a kayak. The Aleutian Islands are located in the Bering Straits at the far west part of the Alaskan Peninsula, reaching across to Russia. Bidarka arrives from the Russian word Bidara, which means boat. In Aleut or Aleut language, they are referred to as Ikyak. The traditional Bidarka or Ikyak frame was made from bone, driftwood, and local saplings, shaped, bent, and tied together with animal sinew. The bone was used in joints as friction bearings to silence the vessel when hunting. The frame was covered in sea lion skin to create the hull, and the finished boat was very fast, able to sustain speeds of 10 knots, 11.5 miles an hour, or 18.5 kilometers per hour. Weighing in at about 40 pounds, or 18 kilograms, it was said to be light enough to be carried by a child. I first stumbled upon an article by Eric Schrade in the 2010 issue of Ships in Scale describing his larger model build. While researching further, I found a more in-depth two-part article by David Zimmerly in the 1983 issue of Small Boat Journal. I settled on a clear plan found on the internet, and on a scale of 1 to 12, the plan was inserted into my draft site 2D drafting program and traced to make templates to build the keel sections, the stern, the transom pieces, and the stem and deck pieces. The 3-piece square section keel, you can see 2 pieces here on the bottom, were made of Castello boxwood. They were made longer to allow cutting in simple overlapping vertical scarp or step joints. The middle and aft pieces seen below are steamed in my repurposed rice steamer seen top left and bent against forms to achieve the gentle curve. The forms were shaped deeper to allow for springback. The forward stem piece at the top right was made as a laminated construction in very thin layered pieces. Once dried and the curves set, the pieces were taken apart, PVA glued, and then clamped back onto the form till dry. The stern post and transom pieces were made from a template, or my templates, and glued onto the keel. The forward deck piece is also in this photo. So there's the forward deck piece, and here's the stern pieces here. You can see the one stern piece going on, and then this one here goes on top of it, which you can see right there. I traced the outline from the template onto the wood using carbon paper and then cut it all out on my scroll saw. This was then sanded down on the tabletop disc sander or an oscillating drum sander. The tool used depended on the shape of the piece. Here, the stem post and deck piece were assembled. There's the deck piece, there's the stem post. And here they are fitted together again and glued in to dry onto the keel piece. At this point, a billboard was made. A top view of my plan was rubber cemented glued to the top with the keel and post supports hot glued to the board to keep things steady. The gunnels were added. These were made from strips of hemlock fir. They needed no steaming as the strips were quite flexible. Here you can see the gunnels. As I needed to make templates for the frames, I created a 3D model of the hull shapes from my plan using Fusion 360 is the program name. And I sliced this up at all the frame locations to reveal the shapes and printed my templates. These were glued onto scrap wood and cut out to make my bending jigs. Each frame was made as a lamination of 3 thin strips of maple. When building in laminations, the pieces must be wider than needed as it can be difficult to align the edges. So I made mine longer also to make them easier to handle. These were steamed, assembled in layers and clamped to their forms, dried, disassembled, glued, reassembled, and clamped. When dried again, they were sanded to the necessary sided and fore and aft thickness dimension, then glued to the keel and gunnels. I started with the main stations and then added the intermediate frames between. Here all the frames are shown installed. The deck beams were installed. That's these two pieces here, or I'm sorry, these pieces here, the deck beams, running athwartships or across from side to side at the main station frames locations. The two ridge beams, which I pointed at in mistake, which are right here, running fore and aft. The two ridge beams running fore and aft above the deck beams were also installed. The beams are made of Castello boxwood. The rising deck beam heights needed to be dry fit adjusted to just touch the underside of the ridge beams prior to gluing everything in position, so it was a bit finicky. You can also see the addition of the floorboards, darker planks, added to take the weight of the hunter down here. These were made from what I believe to be Iroko or African teak for contrast. I had a small chunk of that lying down in my pile of wood and thought it would look good here. The stem and stern were sanded to shape, softening and blending the edges. Holes were drilled for the sinew to tie the various pieces together. I had found 3-strand twine that seemed the correct color for sinew. The strands were unwound, so I used single strands as this seemed more suitable for the size for the job. A number 70 drill bit was used with my Dremel rotary tool to make the holes in the kayak for the sinew. You can see all the holes up here. And here I'm starting to tie some things in. The combing is elliptical in shape to provide the hunter access in and out of the kayak. This was another laminated construction. The final assembly was too wide and deep and a bit wonky in shape. A drafting compass was used to mark off an even width by running the metal point along the inside edge and the graphite point marking the top outer surface. It was then sanded to the line, the pencil line, on the tabletop disc sander to come up with this final shape. Holes were drilled through the side of the combing with a number 66 drill, a bit larger, for the crisscrossing sinew. The hole size, as I mentioned, is slightly larger as the twine needed to pass through the hole twice. The combing was glued to the ridge beams. The side braces were made using stiff cardboard templates to mark off the height, the thickness of the gunnel, and both the thickness and curvature of the combing. So that's these pieces here and back there. The final part was the paddle. I found a design for a Aleutian double-bladed paddle, and so traced it to my build scale, printed it, and glued it to a block of what again I believe to be the Iroko or African teak. This was cut out on the scroll saw and sanded into shape. A wire pin was added to the underside of the paddle so it could be mounted to the combing in a manner insinuating it was in use by an imaginary hunter. Here is the final result set on the hearth tile of my living room fireplace. I thought it looked somewhat like water, so it looked pretty good to me. I made a display case with a clear acrylic dust cover that was made to order, which was removed in this photo, and added a couple carvings I made and painted to fill the corner voids and help reference the scale. On the right is an Aleutian gull with a 2-foot wingspan supported by a drawn piece of bamboo skewer. So that's the post piece that it's sitting on, is the bamboo skewer. To the left is a walrus hopping up from the water. Over here, to scale, I might mention. Here are 2 images of the gull carving completed. Split bamboo for the beak and legs were added. Here it is painted. I had added a split bamboo tongue in the open beak and painted it red. Here is the beginning of my walrus carving. Here I am a little further on, and I've added the tusks. Here it was completed with stiff hairs from my shop brush added for the whiskers. I had recently attended an online NRG seminar presented by Ron Nielsen on making realistic-looking water, and I discovered two things. First, my water was more representative of the warm Caribbean than the cold North Pacific Ocean. And second, there were techniques I could employ to make the water seem more realistic. The cold North Atlantic should be more of a black, green, gray than an inviting blue. So I began by painting over the whole water scene with a black acrylic paint. Next was to create the water disturbances. The major parts were already carved into the block of wood. Since my walrus had just popped out of the water, my splashes were moving outwards from the body in all directions. Once the paint was dry, I applied a liberal coating of 50-50 white PVA glue and water mixture with the paintbrush. Then a layer of single-ply toilet tissue was added. Another coating of watered-down glue was applied over this, and the tissue paper was manipulated with the paintbrush to create ripples in the deeper carved waves. The process was repeated, so the whole water scene was eventually covered with 3 layers of single-ply toilet tissue. Once the paper was dry, a mix of yellow, blue, and a dab of black acrylic paint to create a dark greenish color, and the whole thing received a coat of this. The lower elevations were dabbed with touches of black, and the upper got touches of cobalt blue. Both of these were worked and blended into the dark green. These highlight colors seemed to pop out with the position of the lighting. Titanium white was lightly touched to selected crests in the water. This already looked much better than the original. After waiting more than 3 days to allow the paint to fully dry, I applied the first of 3 coats of what was described to be clear, glossy varnish. I allowed it a day to dry between applications and eventually gave it a total of 3 coats. It dried with a yellow hue to it, which I'm not happy about at all. I've since discovered I should have used either acrylic gloss varnish on acrylic paint or solvent-based gloss varnish as used on oil paintings, or possibly even gloss emotive clear finish, as it never changes color. I think I will try the acrylic gloss varnish next time. The concept of putting the varnish on there is to make it look like wet water. The next step was to create the wild-looking splashing crests on the water. I could use cotton, as seen on the left, or fiber fill, as seen on the right, as I took out of some old cushions. I did some testing on a scrap piece of wood with both materials, using a 50-50 mix of white PVA glue and water, and also testing using Mod Podge glue. The cotton created nice waves and ripples for a smaller scale. The fiber fill worked better for a larger scale. The 50-50 mix worked well with the cotton, but not with the fiber fill. Mod Podge glue worked best with the fiber fill, but I needed to immerse the pieces of fiber fill into a puddle of it, and then set it down with tweezers and a paintbrush, and then work it in with the paintbrush. After it dried a bit, I picked at it with the tweezers to get the desired wild look. Here's the result. It's my first attempt, and I clearly will need more practice, but I'm happy with this compared to what I originally had. Next was to rework the venting on the display case. Vents are added to allow a change of air to remove any moisture in the air that may condense on the inside of the acrylic cover if the model is moved to a different location and experiences humidity and temperature changes. It also vents off gassing from plastics, glues, resins, or paints. I had 2 very small diameter vents in my base inconspicuously located behind the nameplate and on the back outside edge of the black 3D printed mount for my kayak. The locations are identified with red arrows in the top image. Each consists of a stepped hole with a filter paper layer and a metal screen to hold it in place from underneath the base. Having attended a Chicago Deadeyes Club meeting, I discovered my vents were too small. There doesn't seem to be a rule of thumb for the size of these vent holes, or rather the rule is to make it as large as you inconspicuously manage to do. I decided I would have to install this larger screen vent from above as my kayak model was already attached and I couldn't flip it over. I decided to locate this larger vent under the walrus carving. The carving is held in place with two dowels, dry friction fitted to the base, so I could pop it off easily. After outlining the perimeter of the base with painter's tape to help visualize the area, I drilled the largest possible blind hole with the limited size bits I had into the base using a 1.5-inch spade bit. Using a backing board to avoid tearing out, I drilled through the base with a 1 1/8-inch spade bit, creating the stepped hole you see here. To keep out the dust and all forms of tiny critters, I cut 2 round metal screening discs and 1 filter paper disc slightly larger than the 1.5-inch hole. I placed the filter paper between the layers of screening, laid this assembly over the hole, and by using a 1.5-inch wooden dowel, I was able to press them into the hole to rest on the stepped ledge. I cut 4 1/8-inch thick wooden pads and glued these to the display base, which are these 4 pads right here. These pads would raise the carved walrus 1/8 inch above the display base to allow the air a discrete path to vent through completely around and below the perimeter of the carving. Finally, the walrus display was assembled to the base, and I was done. You barely noticed the gap and couldn't possibly realize it was for venting. So, having described what I did here for my venting, I should also mention that Bob Filipowski, when he showed us how he does his venting, he drills one size extra large hole through the bottom, and then he makes a cover, a gasket cover with a hole through it, and he puts his filter paper and screening between his gasket cover and the base from underneath, screwing it in place with wood screws. And then he has little foot pads to raise everything off the tabletop when he puts his model down on the table. So the air can go underneath the base, between the base and the table, and then up through the hole. And usually he hides that either by having what I have here as the dark piece. He'll have a gap between the base and this sub base, so the air can distribute around inside the case. It's something I didn't bother to show here. Possibly I should have if I had a picture of it. Anyway, that's my presentation.